If you boarded a commercial jet today, flying at top speed, it wouldn't take a few months to reach the edge of our solar system. It would take you exactly 5.5 million years. But with our fastest rockets, the math gets terrifying. Sci-fi has lied to you. Even with the most powerful engines ever built by humanity, the real travel times to our planetary neighbors defy all common sense. It takes 7 months just to reach Mars, but here is the impossible truth: it requires mathematically more energy to fly into our own sun than it does to leave the entire solar system entirely. Top aerospace engineers are genuinely baffled by the sheer scale of the abyss we live in. Just how trapped are we? To understand this cosmic prison, we first have to look at the baseline. Space isn't a straight line. You can't just point a rocket at Jupiter and hit the gas. Because everything is moving at tens of thousands of miles per hour, we have to use something called Hohmann transfer orbits, basically shooting blindly into the void, aiming for where a planet will be. But this is where things get strange. The physics of orbital mechanics dictate that the fuel required for a direct, straight-line flight to the outer planets is literally impossible for a rocket to carry. What I'm about to reveal next is the classified level trick scientists use to cheat physics, and it is exactly why thousands of people are joining Deep Space Secrets every single day. If you want to uncover the universe's greatest mysteries with us, hit follow and subscribe right now. You do not want to miss this. Let's rewind to the summer of 1965. A young NASA scientist named Gary Flandreau was mapping out planetary alignments. He realized that reaching the outer planets with normal rockets would take decades, time we didn't have. But then, he discovered a loophole in gravity itself. He found that in 1977, Jupiter, Saturn, Uranus, and Neptune would align perfectly. By bouncing off each planet's gravitational field in a slingshot maneuver, we could multiply a spacecraft's speed to impossible velocities. It was a once-in-a-175-year mathematical miracle. This alignment gave birth to the Voyager missions, and it finally revealed the brutal, actual travel times of our solar system using our best gravity assist tech. Here are the real numbers. The Moon takes just 3 days. Mars is a grueling 7-month journey through irradiated deep space. Jupiter, a minimum of 5 years. Saturn takes 7 years. And Neptune, the freezing blue ghost at the edge of our system, takes a staggering 12 years to reach. It is a mind-bending reality. But it raises an even bigger question. But here is where it gets crazy. Just when you thought you understood the map, scientists realized they had the math backwards. You would think getting to the sun is easy because its massive gravity pulls you in, right? Wrong. Because Earth is orbiting sideways at 67,000 miles per hour, you have to cancel out all that momentum just to fall inward. The Parker Solar Probe took 7 years of complex Venus flybys just to get close. It is literally harder to reach our own star than it is to escape into interstellar space. Chemical rockets are simply too slow for this scale. So, I genuinely want to know what you think. If you had to bet humanity's future on one technology to cut these travel times, what would it be? Are you backing nuclear thermal propulsion, which could cut a Mars trip down to 45 days? Are you betting on solar sails pushed by lasers? Or do you believe we need to unlock classified antimatter engines? Drop your wildest theories below right now. I am reading every single comment, and your input on this matters. Why does this debate matter? Because this affects how we see our place in the universe. If we are ever going to become a true multiplanetary species, these current travel times are a death sentence. A 7-month trip to Mars means astronauts face severe cosmic radiation and muscle decay before they even touch the dirt. Scientists around the world are now realizing that if an extinction-level asteroid is spotted late, we do not have the speed to intercept it in time. We are essentially living in a slow-motion universe, bound by the ancient chains of chemical combustion. Stay with me here, because humanity isn't giving up, and what you're about to see changes everything. We are on the precipice of a propulsion renaissance. NASA's upcoming Draco mission is preparing to test the world's first nuclear thermal rocket in space. Meanwhile, revolutionary projects like Breakthrough Starshot are developing photon sails that could theoretically travel at 20% the speed of light, turning a 12-year trip to Neptune into a journey of mere days. By the end of this decade, you will understand that the terrifying vastness of our solar system wasn't a wall to keep us trapped. It was a test. And we are finally building the keys to unlock the gate. But chemical rockets and impossible travel times aren't the only mysteries lurking in the dark. In our next video, we are investigating the terrifying gravitational anomaly pulling at objects at the edge of the Kuiper Belt. Is it Planet 9, or a primordial black hole? And after that, we are breaking down the leaked DARPA documents on actual warp drive mechanics. You won't want to miss it. Thank you for joining me on this journey. Remember, the true scale of the solar system isn't meant to make us feel small, it is meant to show us how far we have yet to go. The universe is full of secrets, and we are just getting started. Stay curious, keep looking up. I will see you in the next one.